Welcome everyone. I'm just making a quick video here just as an introduction to the measurement topic that we're working out of the textbook, and I really like this unit, but I also see the what am I going to say, the sort of deficiencies in this style of learning, where we are in a textbook, we're doing a lot of work on paper, and there's another side of learning that we're not really catering for here, which perhaps we should, and that is actually getting out and measuring stuff, cutting stuff, building stuff. So there's a whole world of learning that needs to take place there, and when you build stuff, when you're starting out, you do make a lot of mistakes, and you'll go through that phase where the words of the builders are ringing in your ears: measure twice, cut once, because we all make mistakes with our calculations and our measurements, and we end up cutting something at the wrong spot or drilling holes at the wrong spot, and doing things like that where we haven't necessarily planned it out correctly or caught ourselves before we made a mistake. So I'll just encourage you, honestly, to get out there and make stuff, and that's why I've brought in these things here out of my toolbox, just to show you, like, we mostly work these days working in metric units. So there's all my drill bits that I use, and I really like these ones because I think the camera can show you here. They've got this sort of bit here with a 10mm shank on the end, so it fits in the normal drills. There's other things that I use all the time, and I'll just quickly lift this up to show you. Again, we're in a metric world mostly these days, so here's all my open-ended spanners, and there's a ring spanner on the other end of these things here. They're all in millimeters, and when I'm working on something, pulling it apart or bolting something together, I'm using those things, and I'm thinking when I'm buying all the bolts and stuff to join things together, I'm thinking in millimeters, and that's often the way. And it's really interesting when you listen to builders and engineers. They're always working in millimeters. They're trying to work within certain tolerances, and that might be 5 mils, and 5 mils isn't a lot, but that might be the kind of tolerances you need to work within when you're building a house, for example. Okay, for various engineering applications, that's a long way off, and you might need other specialist equipment to help you get things within the nearest thousandths of a millimeter, for example. So you might need a set of calipers to do that. But what we tend to work with is just to the nearest. I'm hoping the camera can pick this up. Is it going to do it? Yes. We're often working within the nearest 5 mils, and you can see it there quite clearly. On this, I like this tape measure because it's got the imperial measurements on the other side of it, because depending on who you're working with, they might be giving you measurements in millimeters or in the old scale in inches and feet. So they're the kinds of things that I use all the time, and somehow we've got to bring it back to what we need to know in the textbook. So the other thing that I'd really like you to think about is that all the pictures and the diagrams that you're working with in the textbook are made with two things, really. They're made with a straight edge, and this is an interesting ruler that all the measurements have almost worn off it, but it provides a straight edge. and it's easy to make the shapes. Now the good news for you guys is that there's no curves that we're working with, so this compass here helps us to inscribe a curve to make shapes, but so far you won't encounter any of that. You'll get shapes made with a straight edge, so you'll have triangles, rectangles and squares, and I think you got parallelograms, and might even be some trapeziums and stuff in there, and some composite shapes made with a combination of those shapes that I've mentioned there. So they're things to look out for. And the final thing I've got to say to you is that the units, hopefully you understand that units are important, and you hopefully understand that we try to do things accurately, and there's some sort of confusion sometimes. I'm just going to put meters squared. When we're dealing with area, sometimes we run into a bit of trouble here when we might write down the number and crunch the numbers, but we don't put the correct units as part of our answer. And not only do we not specify that, but if we're dealing with area, we don't put a little 2 up here to represent meters squared. And so they're the kinds of things, little habits that I'm trying to teach you throughout this unit, is to draw the units correctly. And if we're dealing with volume, that might look like meters. I read this as meters cubed, and I hear students say meters 3 or meters little 3 or something. But you can see the language that I'm using here. I've got meters squared because that little index is a 2, and I've got meters cubed because this is to the power of 3, or what we say is cubed. So they're important. And the other last final tip that I've got for you here in this little introduction is that when you're doing shapes and drawing shapes and sketching out shapes, they don't have to be perfect. And if that was me, I would say to you that that's a square, because these little ticks, even though my drawing is bad, those little ticks there tell me and tell everyone else doing maths that those are the same length. And so that's a square. And you might find that one of those sides might have a measurement next to it, and that measurement might be 6 centimeters, for example. So you know through those little ticks on those lines that every side will be 6 centimeters. And I guess when you're dealing with lines of different length, what we tend to do is use different combinations of ticks. Like this, when I see this tells me this line and this line are the same, but different from the other 2 edges of this rectangle, but these guys are the same. So they're little things to watch out for, and that's what I'd just encourage you to get good at through this unit. The actual crunching the numbers might turn into the easiest part of it, but doing the drawings and doing them well and having the right units on there is a very important part of what we want to do. Okay, thank you. Okay, so that was a long introduction, but I think it's important to talk about those things coming into a unit like this. And the other thing I've got to say is that materials are expensive, and there's work to do on paper before you start building. So I guess that's what we're doing. So what I wrote down here was some common conversions, and we've got 10 millimeters equals 1 centimeter, 100 centimeters equals 1 meter, and 100 meters in a kilometer. I think most students know that, but just to reinforce something really important, I'm always thinking this way, and I know a lot of tradespeople are thinking exactly the same way. They're measuring in millimeters, and they just might say mils. Okay, millimeters, 1/1000th of a meter. So that's what this M stands for, milli, which is 1/1000th of a meter. And that's a thing to think about here. So what I'm going to say to you is, I'm just going to put a line down there and keep all that separate. And what you'll see in your textbooks is something like this, 3 meters, and in brackets it might say something like centimeters. Okay, so the conversion here is that you've got 3 meters times 100 centimeters for every meter. So that looks like 300 centimeters. And you might just jump straight to the answer. That conversion is not so hard. Let's do the same thing, but this time let's go to millimeters. And you might see this straight away, 3,000. Got your answer, great. But if you don't, let's go to the same place here. And what I would encourage you to do is write it out like this, and then come back here and think. The thinking bit is, there's 10 mils in every centimetre. So we might write that and know that we're going to times that by 10. So we might write 3,000 millimetres, for example, if we haven't got this bit down here embedded in our minds about what to do. So let's try a couple of others. Let's stick with simple conversions, and we're going to meters. If you had to show your workings, you might put 2 times 1,000 and then write equals 2,000 meters. It's really important. Can you see at the end of every question, I'm just highlighting things here. I'm actually including the units, and I think that's an important part of this unit. So perhaps let's try one more. We've got 3,400 millimeters. We're going to turn that into meters. Some of you might come in here and set it up this way, asking how many thousands are in there, because you're thinking in this mode already, and your answer might be 3.4 meters. Or I might change the color of my pen here. We might think about it a little bit different. We might go to, from here, millimeters, to dividing by 10, because there's 10 millimeters in every centimeter, and we might land here. And then we might say to ourselves, well, there's 100 centimeters in every meter, so we might work that way as well. They're all things to consider. So converting the units is really important. It's also really important to include the new units on your answer as well, and that's something I'll be looking for. I'm just going to clean the board, and we're going to try a few more questions here. So just quickly free up some space here and look at doing the next little bit. Often we want to do something where we're going from smallest to largest. So I'm going to change up the units here and just throw some numbers out there and see how we deal with that. And so we've got 3 different units here. We need to find some commonality. And I'm wondering here, if we convert them all to centimeters, that might be the easiest way to start with these type of questions. When we've got these different lengths with different units of measurement, I'm looking at this and thinking that it's 54 centimeters, and I'm looking at this and thinking half a meter is the same thing as 50 centimeters. So my final answer, from smallest to largest, may look something like this. I think I'm going to keep that 35 centimeters in the same spot. I'm changing this to 0.5 of a meter, my original values, and then 540 millimeters on the end there. So just finally, we've got a worded question somewhere in our book there dealing with a house on the edge of a cliff. And I think it's 25 meters to the edge of the cliff. And the cliff is receding at something like 40 millimeters per year. And we're wondering how long it will be before the house falls down into the ocean. So let's do these calculations, and I'm wondering if it's 40 mils per year, and our units here are in meters. I'm wondering, we've got 100 centimeters is equal to 1 meter here, and 40 mils is 4 centimeters. So I'm thinking 100 over 4, well, that's equal to 25 years for every meter. And so our calculation here really becomes 25 times 25, which will give us our answer to this final calculation that we need here. I'm kind of running out of a bit of a board here. I know that's going to be 25 squared, and I'm just quickly doing that. 25, 20, and a 5 here. That's 400. Put another 100 there, another 100 here, and 25 there. So that's equal to 625 years until that house falls into the ocean. So they're the kinds of things that we can play around with, and we can think about very carefully, think about converting units and make sure that we're working the correct way when we do some of these calculations. Okay, thank you.